Okay, we're going to continue our examples with u substitution. Um, the directions are simply find the indefinite integral. Now let's turn our attention here. The indefinite integral of x times the quantity x squared plus 1 to the 10th. You may notice this looks very, very similar to that introductory example we did. That one was 2x squared plus 1 to the 10th. So now we're going to investigate what happens when the outside doesn't quite perfectly align with what you would like. If you remember in this example, we took u to be x squared plus 1. And so du over dx was 2x, which was exactly what was here. But that 2's not there anymore. Okay. Well, let's see what happens. We're still going to pick u to be what is inside the parentheses. That does not change. And if u still equals x squared plus 1, then du over dx still equals 2x. That is still the derivative, right? Nothing changed there. I'm still going to multiply the dx to the other side. So all of these steps are the same in both questions. But now we realize, oh, okay, this will become u to the 10th, but I don't have 2x dx to become du. That 2 isn't there. No problem. Because it's a constant, I can divide it to the other side and think of it this way. 1/2 du equals x dx. So the x dx will get replaced with 1/2 du. If it's only a constant that is missing, that is no problem at all. I can divide that over here. I can change constants. Variables, I'm stuck with. I can't do anything with variables. But constants are not an issue. Okay, so here comes the substitution. That will become u to the 10th. The x dx will become 1/2 du, so I'm going to write this like so. U to the 10th times 1/2 du. And I've got the integral, of course, in the front, the stretched s. Now, when it comes to antiderivatives, constants, they act in the same way as derivatives. They just carry along, right? Because you're just going back and forth. So one trick people like to do to make things look a little bit simpler for themselves, any constants that are multiplied in here, I can just move that even to the very front, even in front of my integral sign, like so. I'm going to put that 1/2 even outside of there. So then I've got 1/2 and then the indefinite integral u to the 10th du. Now I can perform that antiderivative. And if you remember, it was 1 over 11, u to the 11 plus c. That 1/2 carries along. So I can simplify that to 1 over 22. And finally, as my final answer, I got to put my u back in. 1 over 22, x squared plus 1 to the 11th plus c. And I've got it. Any of these questions, if you're not sure if you have the correct antiderivative, take its derivative, right? See if you get back to that original function there, right? Here it was that guy. You'll need a chain rule because u sub reverses the chain rule. But okay, if that 11 multiplies down and then it becomes a 10 and then I multiply by 2x, you'll see it will play out. Okay, let's go look at another one. They're getting a little bit harder and we're just seeing different styles. Ooh, this one involves a square root. Indefinite integral 4x squared square root x to the 3rd plus 9. How is this going to work? Okay, well, your first step is to identify what u should equal. This would be a lot more fun if we were in class together and I could say, all right, anybody think they know what u should equal? And maybe people would share, and I'm guessing a lot of people would know. U is always the inside. Well, we'll pick what is inside the square root, the whole thing. U is x to the third plus 9. Okay. You also realize, hey, if you were to take that derivative, you would produce an x squared. And I see x squared here. Now, the constant, the coefficient wouldn't match, but that's not a big deal. The fact that that derivative would have x squared, that's what matters. Well, let's go ahead and do that. My next step is to take this derivative. Du over dx equals 3x squared. I multiplied the dx over. And then I realize, oh, okay, well, there's not a 3, it's a 4. No problem, I'm just going to divide that 3 to the other side. So the 4 can just carry along. It's a constant multiple. The x squared dx will become 1/3 du. And of course, what's inside here is simply u, so I'll have square root u. Let's see it all together. So the 4 just carries along. What's inside there becomes u, square root of u, and the x squared dx, 1/3 du. Everything has been accounted for and replaced with the equivalent, the corresponding u's and du. Okay, before we take an antiderivative, let's clean it up. So if I have this 4 and this 1/3, I'm going to move them out in front of the integral because they'll just be constants that carry along. Also, square root of u, definitely want to think of that as u to the 1/2 so that I can do my antiderivative. Okay, let's go ahead and do that now. So the 4/3 carries along. I left this blank here so we can think about it together. U to the 1/2, well, going backwards, I need to add 1. So that would be 3 over 2. But then that 3 over 2 is going to multiply, and I'm going to think of it, that 4/3 is kind of out there, so I'm going to think I need to cancel out the 3 over 2. Well, what should I multiply with to cancel out 3 over 2? Let's just go for it, 2/3. So multiplying that down would cancel, and it would drop to a half. The 4/3 is just there. Okay, looking a lot better. Multiplying those fractions, and I'm really going step by step for these. I think you may, on your own, feel comfortable skipping some of these steps, or maybe including more steps. I think this is a good amount. So we'll see, we've got 8 over 9. Okay, and then we're gonna, final answer, we need to replace the u with what it was in our substitution way back. It was x to the third plus 9. 8 over 9, x to the third plus 9 raised to the 3 over 2 plus c. If you wanted to check your answer, you could take a derivative. See if you get back to the original. And in this one, you will. Okay, I've got one last example for us. Wanted to do something that involved e. How about this? The indefinite integral e to the negative x times the quantity 1 plus e to the negative x to the 4th. All right, so the first thing is, just recognize, oh, I do not know how to do that as it is. And I'd really prefer not to multiply this out 4 times and then distribute. This has got to be a u substitution. Okay, once you identify u substitution is needed, then what is u going to equal? Be a lot more interesting if we were all in class together. But we're going to take what's inside the parentheses. So always the inside if you want to reverse the chain rule. So we'll take u to equal 1 plus e to the negative x. Okay. Next step after that is to take the derivative, du over dx Well, here we've actually got a chain rule again, right? So the 1 goes to 0, and then the chain rule on e to the negative x, e to the negative x times negative 1. And I'm going to think of that as just a negative in front, and at the same time multiply my dx over to that side. Okay. So now looking at everything, I can tell, all right, what's inside the parentheses will become u to the 4th. This, oh, there's a negative there. I don't want that negative. I want e to the negative x, but that negative is not part of my original function. So that's all right. I'll just move the negative over, like multiply both sides by a negative, if you will. So the negative's over here with the du. No problem. E to the negative x dx will become negative du. And I will have this when I substitute. U to the 4th times negative du. Okay. Continuing from there, I'm going to go ahead and move that negative to the front since it's a constant, right? Negative 1. Then do my antiderivative. 1/5 u to the 5th plus c. Finally, put my substitution for u back in for my final answer, negative 1/5, 1 plus e to the negative x to the 5th plus c. I've got it. There we go. That is the 5.2 lecture. Good luck with homework. I'll see you in the live meeting.